2, 3. Hello students, myself Dr. Divya, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the definitions and terminology in the engineering materials, this module. So define a polymer. So what is a polymer? So polymer is defined as the large molecules that are also called as macromolecules. So how are the macromolecules formed? Macromolecules, they are formed by linkage of small molecules called monomers. So these are all small monomers. So they are linked together to form macromolecules, that is forming a polymer. So polymer can be defined as the large molecules or macromolecules formed by the linkage of smaller molecules called monomers. Okay, so define homopolymer. So we have seen what is polymer now. So we should also understand what is homopolymer. So when the same kind of monomers joins, the polymer is called homopolymer. So if you see this picture, they are all same kind of monomers that are joined together to form a polymer, and this is also called as homopolymer. This is the chemical structure for one of the polyvinyl chloride. So this is the vinyl chloride unit that is repetitive, and the same polymer is used to form a homopolymer. So when a same kind of monomers joins, the polymer is called as homopolymer. Define copolymer. So when different kind of monomers joins, the polymer is called as copolymer. So if you see this picture, this is blue color and this is pink and this is green. It means different chemical structure, different chemical structured monomers are used to form copolymers. So that is that different kind of monomers joins to form a copolymer. Okay, so what is addition polymerization? If you see this addition polymerization, the monomers are forming with the addition of chains due to addition polymerization reaction. So addition polymerization are those in which it takes place without elimination of any simple molecule is called as addition polymerization. It means no elimination of any molecules, only just addition is happening and therefore called as addition polymerization. The next definition is what is condensation polymerization. So if you see here, one molecule is removed from combining two monomers. Two monomers are combined to and eliminates a monomer, that is due to condensation polymers. So condensation polymers are those in which two like or unlike monomers join each other by elimination of smaller molecules such as water, HCl, etc. So depending on the structure, the elimination products will differ. So it can be water or HCl or any other byproduct that is coming out and forming a polymer leading to condensation polymerization. Then what is a resin? So the product of polymerization is called resin, and this forms the major portion of body of plastics, and it is the binder which holds the different constituents all together. So if you see, this is binding agent, that it is like composition is majorly because of these resins that is causing the polymerization and forms plastics. So what is a resin? The product of polymerization, either it is addition or condensation polymerization, will result in formation of resins, and this forms the major portion of the body of plastics, and it is a binder which holds the different constituents together. So different constituents together, the other stabilizers or any other present in that polymer is kept together by this resin. Then what is a plastic? So plastic, it is formed in a desired shape by the effect of mechanical force and heat. So plastic molding machines and all will work on this principle, that the molding of plastic is done with the effect of mechanical force and heat. So what are thermoplastic resins? So the next one is thermoplastic resins. These resins are made of long chains attached by weak van der Waals forces of attraction. So thermoplastic resins are formed by weak van der Waals force of attraction, and these are having long chains. Then what are thermosetting plastics? thermosetting plastics. These resins have three-dimensional network structures, connected bonds. It means the 3D network structures are connected. Okay, so these resins have three-dimensional network structure connected with bonds. So they will be thermosetting plastics. Upon heating, they cannot be, like, they will be going to the next deformation of the shape and they cannot come back to its original shape. So they are thermosetting plastics. Then next one is plasticizer. So what is a plasticizer? Plasticizers are substances added to enhance the plasticity or the property, that is the property of material, and to reduce the cracking of the surface. It means plasticizers, whenever are added to these resins while polymerization, the making of plastics, that is compounding of plastics, what happens? That will increase the plasticity capability of that particular material and reduce cracking on the surface. If at all there is a cracking, the plastic has no use. So therefore, plasticizers are important materials. So it is added to plastics to increase the flexibility and toughness. If you say there are lot of plastics that are flexible in nature and also tough, so that is just because of plastics. Then write the function of lubricant in compounding of plastics. If you see, this is the plastic making machine. So in this, what happens in under pressure and heat, there is formation of some mold, that is the plastic mold. So lubricants will avoid any sticking of this plastic to the machinery. So lubricants prevent molded article from sticking to the fabrication equipment. So lubricants will avoid sticking, because why does it stick? Because it is undergoing the molding at very high temperatures. So sticking will be avoided to machinery, to the walls of machinery or the equipment that is used for this purpose. So that is the role of lubricants in compounding of plastics. Then write the function of stabilizers in compounding of plastics. So stabilizers improve thermal stability during polymerization. Thermal stability is temperature, like at very high temperatures. So stabilizers improve the thermal stability during polymerization. They will not, they will avoid the melting off of plastic after formation. So write the function of, next is function of catalyst in compounding of plastics. Compounding of plastics, the catalyst is also used. So they will, at any reaction, rate is increased by catalyst. So in the same way, in compounding of plastics also, the accelerate the polymerization of fusible resin during molding operation into cross-linked infusible form. So they are forming cross-linked infusible form. So that is what the catalyst work for. So the catalyst will increase the rate of reaction, like accelerate the polymerization reaction of fusible resin during the molding operation and form cross-linked infusible form for thermosetting resins. So during thermosetting resins, we use these catalysts. Then what is a filler? Filler, it is generally added to thermosetting plastics to increase elasticity and crack resistance. It means no cracks will be formed if we use filler in that particular. If at all there are very small pores during molding, the pores will be clogged by this filler. So this is the reaction, like function of a filler, so that there is no propagation of that pore into a crack. So it is generally added to thermosetting plastics to increase the elasticity and crack resistance. Okay. So what is a dye? So dye, we know that it is a color compound that is already always used in many ways. So here also, like, dye is used. These are added to impart the desired color to the plastics and gives decorative effect. It means the plastics will be of different colors. So just because of dyes, the desired color is imparted to the plastics during molding. Then write the preparation of bakelite. So bakelite is one of the polymer that is being formed and used in many of the electronics, knobs and many other things. So these switches and all are made. So it is very hard in nature. So this is formed by condensation reaction of phenol and formaldehyde. Phenol and formaldehyde in the presence of acid or alkali catalyst. Acid or alkali catalyst and at proper temperature or desired temperature that produces bakelite. So bakelite is a hard material or the hard polymer that is used in switches and knobs. So this is formed by the condensation reaction of polymer and formaldehyde in the presence of acidic or basic alkali catalyst at proper temperature. Then what is biodegradable polymer? So the name itself indicates degradable. So it degrades. So biologically it gets degraded after its intended use. So it is a special class of polymer that breaks down after its intended purpose by bacterial decomposition process to result in natural byproducts like such as gases, carbon dioxide, nitrogen, water, biogas or inorganic salts. So if you see this picture, it is very clear, like from day 0 to day 45, the fork is completely degraded and the bottle is also got degraded. These are made from biodegradable polymers. So they get degraded into some natural byproducts like carbon dioxide, nitrogen, water or any of the salts or biomass. So this is coming under the form of biodegradable polymers. Then what is elastomer? So elastomers are also called like rubbers are also known as elastomers. They are high polymers. So they are high polymers which have elastic properties in excess. The name itself indicates elastic properties are present in excess. That is, like examples are rubbers which are used mostly in the automobiles and many of the industries. Then define natural rubber. So natural rubber, it is a high molecular weight hydrocarbon polymer represented by formula C5H6 taken X times. It means the repeating unit, it is the repeating unit. So depending on our product, X times is added. X times is added. It is obtained from a milk emulsion called latex. If you see this, the tree is giving off milk emulsion. So this is called as latex by the tapping or bark of the tree, Hevea brasiliensis. So this is the tree that is used, rubber tree. Normal name is rubber tree. And the botanical name is Hevea brasiliensis. So this tree we extract rubber from this tree and this is called natural rubber and it is a polymer of isoprene units. Repeating polymer of isoprene units. So this forms the natural rubber. Then what is crepe rubber? Crepe rubber, to the rubber latex, a small amount of sodium bisulfate is added to bleach the color and feed into rollers. So it is rolled down to produce the crepe rubber, so which produce 1 mm or more thickness sheets which are dried in air about 40 to 50 degrees centigrade. So after getting the natural rubber, we are mixing with sodium bisulfate and the color is bleached and feeded into roller and that produces 1 mm to more thickness sheets depending on our availability, like capability or the desirable thickness, and is dried at 40 to 50 degrees centigrade. So these dry sheets of rubber are also called as smoked crepe rubber. Okay. So what is vulcanization? Vulcanization is defined by heating the raw rubber in the presence of sulfur at 100 to 140 degrees centigrade. See, if you see, this is the natural rubber that is present. So after heating in sulfur, it is forming the crosslinks. So that will vary the properties. Of that particular rubber. So this vulcanization is important depending upon our desired properties. Next, what is Bunaeus rubber? So this is prepared by Copolymerization of butadiene styrene. So copolymerization, why we are calling? Because two different units are used, repeating units are used here. So butadiene and styrene are copolymerized together to get buna as rubber. What is thiacol rubber? So it is prepared by condensation polymerization of sodium polysulfide and ethylene dichloride. Sodium polysulfide and ethylene dichloride is condensed together to produce thiacol rubber. So what happens in the condensation? There is some byproduct coming out and they form a polymer. So the polymer that is forming from this condensation is, like, one of the example is thiacol rubber. Then define the second part of engineering materials, lubricants. Define lubricants. So lubricants, any substance introduced between two moving and sliding surfaces with a view to reduce frictional resistance is known as lubricants. We generally use in the automobiles to avoid wear and tear. So any substance introduced between two moving and sliding surfaces with a view to reduce frictional resistance is known as a lubricant. Next is, in lubrication we have different types of lubrication. So hydrodynamic lubrication. In this lubrication, the moving surfaces are separated from each other by a thick film of fluid. So thick fluid is applied here. Thick fluid is applied of about thickness at least 1000 angstroms. So 1000 angstroms thickness of fluid is present in hydrodynamic lubrication. Then what is boundary lubrication? Boundary lubrication is defined as that in which the sliding surfaces are separated by very thin. So boundary is like only boundary is covering. Just remember, like, boundary is covering. So this is boundary lubrication. And if it is very thick, lot of lubricant will be used. So that is nothing but hydrodynamic. So if you see, the thickness is high, thickness is low. Thickness is high and thickness is low. Therefore, in boundary lubrication, very thin molecular film of lubricant is used that forms the boundary lubrication. Next is, what is extreme pressure lubrication? So these are additives for which lubricants with a role to decrease wear of parts of the gears exposed to very high pressures. Generally in automobiles, there are gears that are used, so that are exposed to pressures, very high pressures. So extreme lubrications are used in that case. So they are additives that are used to reduce these extreme, like, wear and tear or the spoilage or the damage to the engine parts or any of their parts of the automobiles. So that is just because of extreme pressure lubrication that is happening. And they are also added to cutting fluids for machining of metals. So if at all we want to apply high pressures and cut parts of metals, then we use these extreme pressure lubrication. Next is, what is pour point? So if you see this picture, the pouring capacity is high here, where it is a very medium here, and here it is low. It is easily pouring, it is medium, and this is low. So the temperature at which oil ceases to flow and pour is called as pour point. So it is very simple. The name indicates, like, pour point, the temperature at which the oil ceases to flow, it able to flow and pour is called as pour point. Next is, what is cloud point? So if you see this picture, it is a cloudy in nature, forming cloudy. So the temperature at which the impurities being to separate from solution and lubricating oil becomes cloudy. This cloudy is generally because of impurities present. So whenever there is high impurities, the cloudiness is also more in nature. So cloudy or hazy in appearance. So the temperature at which this cloudy or hazy appearance happens is nothing but cloud point. Next, flash point. So the flash point of a volatile material is the lowest temperature at which vapors of material will ignite. So there are some vapors that are coming out from any of the fuel. So just igniting is nothing but flash point. So given at an ignition source. Ignition source is nothing but the flame that we give. So the source, after we give a source, there is some flash that is happening. That is nothing but the flash point. Next is the fire point. Just above the flash point will be the fire point. After flashing, what happens? It will give off fire. So that is nothing but the happening in the fire point. So the fire point of a fuel is the lowest temperature at which vapor of that fuel will continue to burn at least 5 seconds. At least 5 seconds it will continue to burn. So that is nothing but giving rise to fire point. So after ignition by an open flame. So this is how we test the flash and fire points, and this indicates just flashing is nothing but the flash point. The temperature at which it will at least give rise to fire for at least say 5 seconds is nothing but fire point. So next is the viscosity. So it is a property of a fluid that determines its resistance to flow. So it is an indicator of flow ability of a lubricant oil. If you see this picture, it is good, like good flow is seen, and this is low flow capability. It means it is highly viscous in nature. So viscosity is a property of the fluid that determines the resistance to flow, and this indicates the flow ability of lubricant. Next is the viscosity index. So the rate at which the viscosity of oil changes with temperature is measured by empirical number known as viscosity index. So the rate at which viscosity of oil, any of the oil, changes with temperature is measured by empirical number known as viscosity index. So these are the definitions of engineering materials. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.